All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Is everybody doing good? Yeah? Weather doing all right outside? Yeah? Just careful, because sometimes it can peak really quick. Warm-up number 4 is on the screen. Today, if you notice, aside from simplifying expressions, now I'm bringing in something that we should know, right, which are equations. So I'm just giving you a heads up. Here it goes. Today we're going to go like this. Watch. Catch that? That was pretty quick, right? Here goes again. We're going to go like this. That quick. It is going to go super quick because we're going to already get started with equations and inequalities. So I need you guys focused, all right? So let's see how you do with a warm-up. We got numbers 1 and 2 simplifying and numbers 3 and 4 to solve. So I'll give you some time for that. Let's stay with it, please. And I'm going to take attendance really quick, so just raise your hand to let me know where you're at, okay? All right, just copy that. Oh, by now we are experts at number 1 and number 2. Is that correct? Yes. All right, let's see. Number 1, Alessandra, what'd you get? 11. Hands if you got that. That is correct. How about number 2? Juan, what'd you get? Negative 7x minus 3y or plus negative 3y in any order. Hands if you got that. That is correct. So we got this, right? We got this. So we're putting that baby to sleep. We already covered Monday, Tuesday, and Wednesday of expressions. So today we're going to crank it up a bit, okay? And like I said, we're going to shift gears. Everybody go like this really quick. So bear with me, okay? Because we're about to head into the next dimension. I'm just giving you a heads up. Fair warning? Fair warning. Okay. Look at number 3. To solve this, you should already be done solving these. These are fairly simple, but here it goes. Solution for number 3 is negative 69 equals x. Not the other way around. And we'll elaborate on that as we get there, okay? This one, x equals negative 5. And double check that, yeah? Some of you are like, Q, come on. I get it. But like I said, we're going slowly. Baby steps, yes? All right. How are we doing? Good? All right. Agenda for today. Copy this underneath. Here we go. We got warm-up number 4 done. What lesson are we looking at today? Equations and inequalities. Okay? And your home plate for tonight is only 8 problems. Solving equations and inequalities. Only 8 problems. Only. All right? Yeah, underneath the warm-ups. Every time you finish the warm-up, this goes right underneath. Okay? So whenever I get to the point, check this out. Like I said, throughout the year, throughout the semester, we're going to be having pop parties every other Friday. And hint, tomorrow is Friday. So that's 25% of your grade. Your home plates, when you turn them in, are 25% of your grade. Your semester final, when we get to the end, we do a cumulative. That's 25% of your grade. And then I'm going to be checking your notes and notebook to make sure you have all the warm-ups and everything in order. That's 25% of your grade. So make sure you're keeping up with your organization. All right? Yes, Mr. Q. All right, good. Okay, we good? How about now? Okay. All right. Now check this out. After this, I usually go to I give you a Nearpod code because at times we're going to be here in class using our Chromebooks, and I'm going to be using that tool so that we can interact here in class. But since some of you have not gotten your Chromebooks yet, I'm going to take a little pause for that. But the next screen would show this. Look up. And then you would copy that code, and that would help you log on during class. And then I'll give you another code for you to take home, and you can do that on your own at home. Okay? Now, if you copy that code, it's not going to work because this is from a year ago or so. Okay? It's deactivated. However, the very next thing I usually ask for is the previous home plate. Get that in front of you. But now check this out. Today I'm not going to have you go over that one with your neighbor. I'm going to have you put your name, date, period on it, tear it out, pass it all the way to the back, and the last person take it to our awesome TA, Brooke. She's sitting over there waiting in the back for work. Make sure you take all the stack of papers over. Yeah, turn it in. You want to get it back? Not soon, so you're probably going to have to get the notes from someone. All right. Yeah?
I have my homework and my notes today.
Yeah, so you're going to have to do new notes. Woo! Let's go.
Sorry, but like.
Yeah, you're going to have to do new notes, yes. All right. All right, so what are we learning? That the home plate, make sure you copy it in a separate sheet because I'm going to be asking for the home plate from time to time. Yes? All right, so we'll go ahead and tear it out. And if you need to take notes again on whatever lesson, make sure you take notes. Send that back to our awesome TA, Brooke. The other thing I need from you is the signed syllabus. Signed syllabus. I only need the back sheet. Turn that in over there also to Brooke in the back. And once you get back to your seat, home plate for tonight is posted on the screen. Copy that. I'll give you 5 minutes. Copy and go. Yeah. So, let's see how we're doing with our process for our daily tasks. Did we start with a warm-up? Yes. Did we copy the agenda? Yes. Did I ask you to get your previous home play out? Yes. We didn't go over it this time. We turned it in. Okay. Did we copy tonight's home play? Yes. All right, so usually at that point, we get started with the lesson. So at this point, you turn your paper over, and in the back, I want you to set it up for Cornell Notes like we did the other day. Set it up for Cornell Notes. The back side, you should have a full sheet, page ready for Cornell Notes. Yes, sir? Yeah, the back side of the home play and agenda, it's blank, right? Or if you are at the end of the back side, then start a new page. Yes? Am I talking crazy over here? No? All right. Let me do this. All right, here we go. Here's my warm-up and then agenda, yes? You turn the page and you should have a blank sheet right here, yes? Cornell Notes right here. Yeah? Why? So like that it keeps organized and it flows. Does that make sense? Everything stays together, okay? Not like the socks that all of a sudden end up in the dryer and you are missing one, right, from time to time. Why is that? Have you guys noticed that? That's crazy. All right, so with that said, at the bottom left of your Cornell Notes, we write our objective. I can solve one variable equations and inequalities. Here it is. I can solve one variable equations and inequalities. I can solve one variable equations and inequalities. By now, by looking at the objective, you should know what the main concept for today is. Tell your neighbor, please, main concept for today. Yeah, now we're moving on to one variable equations and inequalities, and what are we doing with that? We're going to solve them, okay? So, like I said, today's going to go a little fast, but this should be like review, okay? But yeah, I'm going to take it baby steps. We're going to start with a little bit baby steps, but then all of a sudden it's going to be like you're on a bike when the bike's on fire and everything else is on fire. So, you know, we'll get there, okay? All right. So with that said, everybody got it? All right, so write your utensils down, look up to the screen. I'm going to do a soft reintroduction of equations and inequalities, which you should know, and your teachers in the past in Algebra 1, they should have already done as well. But I like to introduce it like this. Okay, and you're not to copy anything, just pay attention. Write your utensils down, look up to the screen. Here it goes. Now, equations come from balanced scales. You guys seen this scale before? They usually have it at places that have jewelry because they weigh gold and stuff like that very meticulously. So how these work is that if I was to place some weight on one side, what's going to happen to that side of the scale? It's going to drop. That is correct. So at this point, it's not balanced, which means it's not equal. That means what do I need to do to this side to make it balance again? Add 8 to that side, and that's how it balances out again. That's the whole idea of equations. That's why your teachers in the past told you whatever you do to one side, you do to the other side, because it needs to be balanced. So when it's balanced, it's an equation. We got it? What if I add 3 more to the right side? It's going to drop, which means I need to add what? 3 more to the left side, and that's balanced. Okay? You're like, oh, I get it, Q. All right. Now, from that same idea, though, guys, look up, comes this next one. If I have a balance scale that looks like this, that is not balanced. That means not equal. That means I have 8 here and 11 here. But if I look at this scale, can you picture where the bar was originally when it was balanced? Can you picture it? That's right about there. Is that correct? Do you see what it forms here? Yeah, the inequality symbol. You're like, what? So inequalities are basically not equal to each other. That means that one side is greater than the other. That's where we get that symbol from. Kind of like if I go back also the other way, if I do this, same thing, check this out. I have 8 on this side, 0 on this side. The original bar was over here, so that means my inequality symbol is like that. And these are what we're going to be doing today. And hint, hint, wink, wink, tomorrow's Friday. Just want to throw it out there so your noodle can be thinking about that. All right, good intro. Is everybody remembering equations and inequalities? Yeah? You're like, yeah, we haven't seen it like this, Mr. Q. They showed us alligators and Pac-Mans and whatever for inequalities. Well, no. All right? With that said, yesterday, or the day before, we started our Cornell notes. We had our objective at the bottom left. At the top, we had made a table. Is that correct? For the number sets. But we're done with number sets. At that space at the top of your paper, I want you to draw the Frere model, this next one. That Frere model, I want it drawn at the top of your page. So make 4 partitions, one of them at the top left, definition, top right, critical attributes, bottom examples, bottom left, and non-examples at the bottom right. And in the middle goes one variable equations and inequalities. Set that up, please. And I'm going to give you the definition, might as well. Here it goes. 2 expressions equal or not equal to each other that contain one variable. Copy that. I'll give you some time, and I'll elaborate. Copy and go. Today we're looking at one variable equations and inequalities. The definition given is 2 expressions equal or not equal to each other that contain one variable. Now let me first elaborate what that means, and then I'm going to give you some examples for you to write in the example section. So write your utensils down, look up to the screen. There it goes. It says 2 expressions. Okay, I'm going to write an expression. I'm going to write Q minus 5. What kind of expression is that? It's an algebraic expression. Did we cover that yesterday? Yeah. How about this one? Is that an expression? 23. 23. Yes, it's a numerical expression because it's just a number. Okay? But according to the definition, it says 2 expressions equal to one another. So in order to make these equal, I just do this. Do you see an equation now? Yes. But it's particular because it only has what? One type of variable. Do you only see one variable in the whole thing? Yes. But it says equal or not equal. What do we know about not being equal? What kind of statement is that then? an inequality. It's either equal or not equal. Did this clarify the definition a little bit? Yes? So, for examples, write these down. I got x plus 2 equals to 25. Are there two expressions equal to each other? Yes. 3x plus 2 greater than or equal to 25. Are there two expressions? Yes. But it has an inequality. That means that they are not equal. Let me show you another pair. 12 equals y minus 8. This one, 12 less than 4y minus 8. Another 2a equals 14. This one, 2a plus 8 less than or equal to 14. And the last one, negative 3 equals m divided by 4, and negative 3 greater than m divided by 4 minus 6. Now let me scoot this up for those of you that can't see from the back. There they are. Now, once again, we have two expressions equal to each other and two expressions not equal to each other, and each of these only have one type of variable. This is x, this is y, this is a, this is m, and so on and so forth. They're like, come on, Q, hit me. We got this, yes? All right. So, students, one variable equations and inequalities. There you go. All right. So, with that said, zoom out. Look up to the screen. I'm going to show you none examples. Don't copy them. Just look at them first. And tell your neighbor why the first one is not a one variable equation. Why is the first one not a one variable equation? All right. Now tell your neighbor why the second one is not a one variable equation. Yeah, pretty good? Yes? All right, let's see. How about the first one? Why is this one not a one variable equation? JP? Does it have an equal sign or inequality sign? Okay, bonus question. Then what do we call this? Tell your neighbor. If it's not an equation or inequality, what do we call that? Everyone, it's an expression. That's where we come from, yes? We're going from expressions now to statements. Okay. The second one. Why was this one not a one variable equation? Caleb? Two different variables. Okay. Bonus question. What would be the name of this one? Think about it first. Tell your neighbor the name of that one, please. I think Valente's got it. He just told Fredo the name of this one. What is this one's name, Fredo? Sorry? This one, the name for this one? Help him out, Valente. Okay, Zoe, take it. It's an equation. What kind of equation, everyone? Two variable equation. Today we're only looking at one variable. You see how things make sense once you start breaking it down? They should make sense, okay? So if I was to ask you to take a picture and put this on your Insta, what would you hashtag what one variable equations are? Hashtag what? One for life. Yeah, I'll take that. Yeah. Okay, and in parentheses, I'll just put variable. Yeah. I would put hashtag no expressions. Because it cannot be an expression. They have expressions, but it cannot be an expression. Okay? I also would add hashtag Bam! Let's go. All right. So today I'm going to show you a process. It's only 4 steps, simple steps. I only want you to copy the first word on each of the steps, yes? So you can remember the process that we're going to do today. Copy this underneath for your model. Steps. Only the first word of each step, and I'll elaborate so you can see what we're doing for each of those steps. So we have step 1, simplify. What are we simplifying? We make sure that each side of the equation or inequality is simplified, which means you can combine like terms, you can, yes, underneath the Ferrier model, yeah. Step 2, we isolate the variable. Now, for those of your friends, I'm pretty sure you've never gotten a referral, but some of your friends gotten referral, and it says on the referral, isolation. What does that mean? That they take them outside or they send them elsewhere. That's when you leave by itself. So step 2, we need to leave the variable by itself. And what do we use? We use inverse operations. We'll talk a little bit more about that. Step 3, we're going to plot our solution on the number line. And step 4, we're going to check. So 4 easy steps. Simplify, isolate, plot, check. 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 Okay? All right. So as promised, I'm going to start slow, but then it's going to get going pretty quick. So stay focused. Here we go. Y'all ready? So we know what we're looking at, one variable equations and inequalities. Now let's get to solving them. Ready? Here we go. Okay, don't copy these. These are baby equations. They are known as one-step equations. Why are they one-step equations, Mr. Q? Because it only takes 1 step to solve. So check this out. You're just paying attention. I'm going to zoom in. Look at this one. Writing utensils down, look up to the screen. Here it goes. I have the equation x plus 2 equals to 25. To solve, me, Mr. Q, I like to do this. I need to set it like if it was a balanced scale. There it is. Now I have one side and the other side, yes? I ask the question, can I simplify the left side anymore? Can I combine or do anything here? No. Can I do anything on the right side? No. So I go to step 2. Isolate the variable. What does that mean, Mr. Q? That I need to leave the variable by itself using inverse operations. Now, this is where some of you got confused in the past. Let me clear this up. When someone takes a number and does a lot of operations to it, they use what we call the order of operations. And then we end up with an equation that looks like this. But in order to undo the equation, we need to go in which direction now? Backwards. That means that we're going to start with wherever we see addition and subtraction first, and then we tackle what? Multiplication and division. So therefore, what operation do you see here? Addition. So therefore, what is the inverse of addition? Subtraction. And we end up with x equals 23, Michael Jordan. Step 3, plot your solution on the number line. Step 4, check your solution. How do we check it? Well, what's our, my goodness. Give me a second. All right. What is our possible solution that we came up with? 23. I need to substitute that in here. And now we should have a balanced scale. Let's see. Is this the same as that? Yes. Copy that. This is known as example Q. Yeah, straightforward. You're like, Q, come on. Give me something. All right, let me zoom out. Copy this one down here. This is example super Q. Example super Q. Negative 2a equals 14. Let's do that one together, yeah? All right. Let me get you started. Here we go. Bam. Pretty good, right? Yeah? All right. Question. Can I simplify the left side anymore? No. How about the right side? No. So let's go to step 2. Isolate the variable. So circle the variable that we need to leave by itself. There it is. What operation is happening between the 2 and the a? So what is the inverse? Divide by negative 2, divide by negative 2. A equals negative 7. And if I was asked to plot it and check it, we know how to do that, yes? Okay. All right. Now, we're not going to do these two. Don't copy them, but help me out. Look up, please. Don't copy these. Can't simplify, can't simplify. So here we have subtraction. What is the inverse? We add 8, and the rest is history, yes? How about this one? Can't simplify, but what is going on here? Division, so we do what? Multiply times 4, multiply times 4, and so on and so forth. Okay? From 1 to 5, is it coming back? Yes? 5? Yes? Shall we crank it up? All right, these were baby steps. These are one-step equations. Guess what's next? Two-step equation. So copy this one, please. Example, super Q. Oh, wait. Did we do super Q already? All right, so let's do mega Q. Example, mega Q. We got negative 5x plus 12 equals 37. Negative 5x plus 12 equals 37. All right, let's do this one together. Line down the equal sign. Can we simplify the left side anymore? No. How about the right side? Can we do anything to the right side? No. All right, so question. We go to step 2. We need to isolate the variable, leave the x by itself. What operation is happening next to it, right here? Multiplication. What operation is happening here to the other side? Addition. So according to the order of operations, we're going backwards, right? So we start with addition, yes? So what is the inverse? Minus 12 minus 12. We got negative 5x equals 25. And last but not least, what is the inverse of multiplication? Division. Divide by negative 5. Divide by negative 5. X equals negative 5. Coming back, yeah? All right? So, copy this one. Example, Shazam Q. Example, Shazam Q. Negative 7 equals m over 9 minus 12. And let's see if you can do that one by yourself. Let me help you out really quick. There you go. Copy and go. All right. Let's see where we're at. Can we simplify the left side anymore? No. Simplify the right side anymore? No. Step 2, isolate the variable. We need to leave m by itself. What operation do we have here? Division. What operation here? Subtraction. Where do we start? With subtraction, what is the inverse? We add 12, add 12. We end up with 5 equals m divided by 9. So therefore, at the end, what is the inverse of division? Multiplication, multiply times 9, 45 equals m. Hands, have you got that? All right. We got this, yes? My goodness, Fly, you bug. Oh, get it? You bug? That's pretty good. Yeah. So, step 1, step 2. From 1 to 5, how comfortable are you with these? Okay, 5, 3, 5, 4, 5, okay. Let's crank it up a notch, yes? All right, so we went from 1 step to 2 step. From this point forward, we don't call them 3 steps, we call them multi-steps, because sometimes it's going to take us more than 3 steps to solve. So, copy this next one. Example, Star Wars Q. Give me a second. Example, Star Wars Q. 2/3 R plus 3/4 equals 7/12. Just copy it. I'll elaborate on this one. Some of you are like, not these again. Yes, they're back. Kind of like polynomials. Polynomials are never going to leave your mathematical world. You're going to be walking to Donut to go get a nice tea and something, and at the corner you're going to hear, you turn, polynomials. There you go. All right, here we go. Writing utensils down, look up to the screen. Let me get you started. Now, I know working with fractions sometimes it's a little bit hectic. So in order not to work with fractions, we need to make sure we get rid of the fractions. How do we do that, Mr. Q? Well, first, I need to first look at the denominators. Look up 3, 4, and 12. We have 3 denominators. I want to look at the first 2. A common denominator between 3 and 4 would be 12. So if these 2 is 12 and this one's already 12, our common denominator for all 3 is 12. That means I'm going to multiply the entire equation times 12. How do we write 12 as a fraction? Over 1. So I'm just going to distribute that one step at a time. Let's do that together. Write that down, please. So let's go one step at a time to distribute. 12 times 2. 24 over 1 times 3 is 3, and that is R. Plus 12 times 3. What is 12 times 3? 36, and 1 times 4 is 4, equals, what is 12 times 7? 84 over 1 times 12 is 12. You're like, Q, it's still fractions. I know. This next step will get rid of the fractions. Let's simplify it. What is 24 divided by 3? 8R. What is 36 divided by 4? 9. And what is 84 divided by 12? 7. And do you know how to solve it from there? Yes. Finish it off, please. Or let me help you out. There you go. So, can't simplify. We have R to leave by itself. That means we have multiplication and addition. So I'm going to start here. Minus 9 minus 9. We end up with 8R equals negative 2. And the last step, inverse of multiplication, is division. So R equals negative 2/8, but simplified is negative 1/4. Are we doing? Yes? All right, let me give you one for you by yourself. Do this one by yourself. This is example, let's do example Power Rangers Cube. There you go, Power Rangers Cube. 2/5 x plus 3/10 equals 1/20. All right, and to get us started, we need to look at the denominators, right? So, Diego, Rosas, between 5 and 10, what is the common denominator? 10. Okay, so for these two, it's 10. So we have 10. How about between 10 and 20? What would be our common denominator, Lorena? 10 and 20. Can we make a 10 into a 20 by multiplying? Yes. So our common denominator is 20. That is correct. So we're going to multiply everything times 20 over 1. I'll give you some time for that. Copy and go. All right, let's see. Tell me what to write. Jose, what did you write next right here? Plus? That is correct. Continue, Zoe. Okay, help her out, Jaden. Okay, so? Okay, continue, Fredo. Oh, you're up to right here? Okay. Help him out, Valente. Subtract 6. 8x equals negative 5. And last but not least, everyone, divide by 8. X equals negative 5/8. I forgot to put the negative there. Okay. Hands if you got that. All right. So far okay? Kind of, sort of. We're getting there. Our noodle's starting to turn. Shall we crank it up a little bit more? So we're like, no. Well, we are. Let's go. Let's go. Copy this one, multi-step equations. You're like, what, Q? Oh, yeah. All the baby steps are done. Let's go. This is example, how about MJQ? Let's go. We got negative 8x minus 21 plus 5x equals negative 15. Let me get you started. There you go. All right. For the sake of time, let's do this one together. Can I simplify the right side over here? No. How about the left side? Yes. Negative 8x and positive 5x give us what? Negative 3x, and then bring down the negative 21 equals to negative 15. We have two operations, multiplication and subtraction. I start with the subtraction, so I add 21, negative 3x equals 6, and last but not least, this is multiplying, so what is the inverse? Divide by negative 3, divide by negative 3, x equals negative 2. Woo! Let's go. Yes? Okay. One last one. I know some of you are like, what? Yeah, last one. Because if you notice, we've been doing just equations, right? You're like, oh no. Oh yes. Copy this one. And we're going to call this, bam, example. How about Michael Jackson Q? Yeah? Negative 8x minus 21 plus 5x less than or equal to negative 15. And if you notice, it's exactly the same as the previous one, right? Why did I do that? Because the process is the same. So what do? Combine. That leaves us with negative 3x minus 21 less than or equal to negative 15. Then what do? Add 21, negative 3x less than or equal to 6. This is where I wanted to get to. Look up to the screen. What do I do next? Divide by negative 3, divide by negative 3. However, look up. X greater than or equal to negative 2. So you never why I did that. Why did I do that? Yeah, just remember for inequalities, whenever you are multiplying or dividing by a negative, you need to flip the symbol. Flip the symbol. Flip the symbol whenever you multiply or divide by a negative. That's why I flipped it from here to there. We got it? All right, from 1 to 5, how comfortable are we, Lee? Yeah, we got this. So your home plate for tonight is only 8 problems. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.